Welcome back. In the last video we have seen the relationship between the angles when the angles are intersecting with each other, and if you remember, the vertically opposite angles are same. Now let's look at the condition where there are two lines and they are intersected by two transversals. The line which intersects two parallel lines is called as transversal. So let's try to establish relationship between all these angles. Before moving ahead to find out the relation between the different angles, let's try to know what are the different types of angles we have here. We have two parallel lines here. Let me just try to denote them as L and M. That's how we do angles. We can do by single line also. And let us say this is equal to P and Q. So PQ are parallel lines which are intersected by two parallel lines, again L and M. So these are all two parallel to each other, and these two are also parallel to each other. Now this is a parallel line Q. What you have done, just you have raised this whole line to another position, but you haven't tilted it. You haven't tilted it. You haven't changed the angle. You just moved it like this. So by looking at it, you can say that this angle and this angle, I mean to say 1 and 5, 2, 6, 4, 8, 3 and 7 will be equal to each other, right? Because what you have done, you have taken the straight line and you have just moved it. You have just moved it in the, without changing the angle, you have just moved it to the different location. So they are parallel to each other. So they will be making the same angle. These angles are called as corresponding angles. Let me say corresponding angles as C, interior angles as I, exterior angles as E, just for our convenience so that we can shorten them. Okay, let's see what are the corresponding angles. Corresponding angles are 1 is equal to 5, 1 is equal to 5, 2 is equal to 6, 2 is equal to 6, and 3 is equal to 7, 3 is equal to 7, 4 is equal to 8. 4 is equal to 8. So we were able to tell, since the angles are same angle it should make, because it's a parallel line. You just moved it and created another parallel line, but you haven't tilted it. So two parallel lines will make the same angle. So those angles are called as corresponding angles. Yeah. And let's also know what are interior angles and exterior angles. See, we have here two parallel lines. Whatever the angles you have inside the parallel lines, two parallel lines, that's 3, 4, 5, 6, 3, 4, 5, 6, they are called as interior angles. And similarly 1, 2, 7, 8, 1, 2 and 7, 8 are called as exterior angles. So the angles which are between those two parallel lines are called as interior angles. The angles outside the two parallel lines are called as exterior angles. Now we have just now proved that whenever two lines are intersecting, the vertically opposite angles are equal. We have that, right? We already learned that. What we learned? We learned that vertically opposite angles are equal. Can I say that as V? Okay. Let's go ahead and see. If I apply C, what happens? If I apply C, for the convenience, I have given them in the same color. You can see that all vertical opposite angles, these two are in yellow color and these two are in green color. Now if you look at the vertically opposite angles, 1 is equal to 3, 2 is equal to 4 and 5 is equal to 7 and 6 is equal to 8. That's about vertically opposite angles, right? Now from these two, can we derive any relationship? That's what we want to see. Now let me repeat again. Corresponding angles are same. We know corresponding angles means the angles which are at the same position. So here I am making an angle of 1. Here suppose I am making an angle of 5. They both will be equal because they are corresponding to each other. And we also know that vertically opposite angles are equal. So 1 3 equal to 2 4 and 5 7 equal to 6 8. If you take these two and let's try to arrive, we can see actually we can establish any relationship. So let me just try to erase this. Let's erase this part. Okay, right. Now we know angle 1 equal to angle 5, but angle 5 is equal to angle 7, and angle 1 is also equal to angle 3. So what is this? Now we are arriving at, we are saying that angle 1 is equal to angle 3 is equal to angle 5 is equal to angle 7. Similarly, can you get the other relationship? That's angle 2 is equal to angle 4 is equal to angle 6 is equal to angle 8. Okay, right. Now what we are saying? Angle 1 is equal to angle 3 because they are vertically opposite angles, which is equivalent to angle 5 because they are 1 and 5 are corresponding angles, and which is also equal to angle 7 because 5 and 7 are vertically opposite angles. So if you see here, 3 and 5 are equal. We just discussed that 3, 4, 5, 6 are called as interior angles, but 3 is on one side and 5 is on other side. So we call them as 3, comma 5 and 4, comma 6. They are called as, its angle is there actually, pardon me, 3 5 4 6 are called as interior alternate angles. Alternate interior angles is a better way. We'll say them as alternate interior angles. So let me just erase this so that it's easy, so that no confusion there. I'm erasing this part. Now this is what we have arrived. What we have arrived? We have used corresponding and we have used the vertically opposite angles, and we arrived at this particular condition that angle 1 is equal to angle 3, which is equal to angle 5. So angle 3 and angle 5 and angle 4 and angle 6 are called as alternate interior angles. They are equal. So the number 1 is number 2 actually. The one is corresponding angles are equal. Number 2 is alternate interior angles are equal. Alternate interior angles are equal. Okay, let us see anything else we can conclude from this. Okay, what else we can derive from this? See here, angle 1 and angle 2. 2 is equal to angle 4 because they are opposite to each other, and similarly I know that angle 1 is equal to angle 5 because they are corresponding angles. So if I take interior angles, I am only talking about interior angles. We established one relationship that opposite interior angles, we'll say alternate interior angles are equal. Now we are going to establish another relationship, that is interior angles on the same side. That is, these are interior angles on the same side means either 4, 5 or 3, comma 6. They both add up to how much? Suppose you take 4, 4 is nothing but equivalent to 8, 5 plus 8 is how much? These two are non-common sides and this is a ray standing there. So this sum should be equivalent to 180 degrees. So what is that we are saying? We are saying that interior angles, that's angles on same side, what you will say if they are adding up to 180 degrees? We will say are supplementary. Interior angles on the same sides are supplementary. So we are able to derive 3 points from this one. The corresponding angles are equal. We don't need to do any proof for that because it's just common sense. We have taken the parallel line, we have taken a line and we have just created another parallel line. Parallel line itself says that you are not modifying any angles. So the corresponding angles are equal. Now we have used corresponding angles and vertically opposite angles, and we are able to derive that angle 1 is equal to angle 3 is equal to angle 5, angle 3 is equal to angle 5. That's nothing but interior opposite angles are alternate interior angles. Interior opposite angles are equal, and also you can see that interior angles on the same side are supplementary, because if I have 4 and 5, I can take them here or I can bring it here. If I take 4, 4 is nothing but equal to 8, because 4 and 8 are corresponding angles. So 5 plus 8 is 180 degrees. So I say interior angles on the same side are supplementary. These are very important with respect to the parallel lines. So 3 points: corresponding angles are equal, alternate interior angles are equal, and interior angles on the same side are supplementary. Now let's go ahead. We'll stop here. We'll continue in the next video. In the next video, what we'll be doing is we'll be solving some problems with respect to the vertically opposite angles, linear pair of angles, and also with respect to the parallel lines. Thanks for watching. Thank you. Bye bye.